In today's world where digital financial transactions are becoming increasingly dominant, cryptocurrency stands out as a global phenomenon. Digital currencies like Bitcoin have become symbols of innovation and decentralization. However, among all these cryptocurrencies, Ethereum has proven to be one of the most influential. Since its creation in 2015, Ethereum has not only been a digital currency, but also a platform that enables the creation of smart contracts, decentralization of systems, and the building of decentralized applications, DApps, allowing transactions to take place without the need for intermediaries like banks or other financial entities. The foundation supporting Ethereum goes beyond simple value transfer. While Bitcoin focuses on being a store of value and a medium of exchange, Ethereum aims to solve problems of scalability and flexibility within a broader ecosystem. Its ability to create smart contracts, which are automatically executed when certain conditions are met, has transformed the way financial, legal, and commercial agreements are made. With this, Ethereum has built an infrastructure that is much more than a currency. It is the foundation of a new, decentralized digital economy. However, as the demand for Ethereum grows, the challenges in ensuring its scalability, security, and speed also increase. With millions of transactions taking place every second, Ethereum faces the need for more efficient, faster processes that can sustain the constant increase in users and developers. Ethereum mining, a central process in validating and securing the network, is the answer to many of these challenges. But as the system expands, the need for more robust and sustainable solutions becomes evident. This is the landscape we will explore throughout this journey, understanding how Ethereum mining works and its impact on the digital revolution we are living through. Ethereum mining is a fundamental process for the functioning and security of the Ethereum network. In simple terms, mining is how transactions are verified and added to the blockchain, which is the decentralized digital ledger of the network. To validate transactions and ensure they are legitimate, miners compete to solve complex mathematical problems using computational power. The first miner to solve this problem receives a reward, which is a certain amount of Ether, ETH, the native currency of the Ethereum network. Additionally, mining helps maintain the integrity of the network, making it harder to hack or corrupt, as it requires a significant computational effort to alter any data on the blockchain. Ethereum mining uses the proof of work, POW, consensus algorithm, which requires miners to perform complex computations to find a valid hash. This hash is a unique sequence of numbers and letters that represents a block of transactions. Each block, when validated, is added to the chain of blocks, the blockchain, and the miner who finds the correct hash is rewarded with an amount of Ether. This process not only keeps the system secure, but also allows new coins to be issued in a controlled manner to miners, incentivizing participation in the system and ensuring its decentralization. However, Ethereum mining is not just about validating transactions and creating new blocks. Mining also plays a crucial role in decentralizing the network, as instead of relying on a central authority to validate and ensure the security of transactions, anyone with the right equipment can become a miner. This means that the Ethereum network is not controlled by a single government or entity, but by a global network of participants. However, as the network grows, scalability challenges arise, with an increasing number of miners competing to validate transactions and the need to optimize processes to ensure the network continues to operate efficiently. Proof of work, POW, is the consensus mechanism used in Ethereum to validate transactions and secure the network. Essentially, it requires miners to solve complex mathematical problems to find a specific value, known as a hash. This hash is a unique sequence of numbers and letters that represents a block of transactions. The goal is to ensure that the miner has performed significant computational work to validate the transactions, making the network more secure and resistant to attacks. For each new block of transactions added to the blockchain, a new mathematical problem must be solved, which requires considerable computational power. The POW process ensures that the Ethereum network is not controlled by a single entity or group, promoting decentralization. This happens because any miner can join the network and compete to solve these mathematical problems. However, as the difficulty of the problems increases with more miners entering the network, the computational power required also grows, making mining increasingly challenging and expensive. While proof of work is an effective way to ensure the network's security and integrity, it has been criticized for its high energy consumption and environmental impact. Despite the criticisms, proof of work has proven to be robust over the years, maintaining the security and decentralization of Ethereum. However, with the continued growth of the network and the increasing demand for energy, Ethereum is evolving to a new model, proof of stake, POS, which aims to solve the limitations of POW, making the network more scalable and sustainable. For now, however, POW remains the foundation of Ethereum mining, and its impact on the network's security and efficiency is undeniable. Understanding how proof of work functions is essential to grasp the importance of mining in Ethereum and the challenges the network faces. Ethereum mining is not just a computational process. It involves an extremely sophisticated infrastructure composed of hardware, software, and a robust communication network. Miners typically use graphics processing units, GPUs, to perform the complex calculations required by proof of work. GPUs are more efficient than traditional processors, CPUs, in executing these calculations, allowing miners to solve more hash problems in less time. In addition to GPUs, miners also require high-performance motherboards, stable power supplies, efficient cooling systems, and high-speed internet connections to ensure mining data is processed without interruptions. The mining infrastructure also extends to large-scale mining farms, massive facilities with hundreds or even thousands of mining rigs, typically located in remote areas where energy costs are lower. Each rig can consume enormous amounts of energy, and the efficiency of a mining farm directly depends on the proper setup and maintenance of all its components. Large-scale mining also allows miners to join forces in mining pools, where they combine computational resources to increase their chances of solving mathematical problems and receive a share of the rewards proportional to each miner's contribution. The constant evolution of this infrastructure reflects the growing demand for greater computational power as the difficulty of mining operations increases with Ethereum's expansion. Miners are constantly upgrading their equipment and seeking technological innovations, such as application-specific integrated circuits, ASICs, which are designed to optimize the mining process even more efficiently. While these devices are not as popular in Ethereum mining as they are in Bitcoin mining, they are starting to be used to face the increasing competition within the network. Therefore, Ethereum's mining infrastructure is dynamic and essential to ensure that the network remains secure and continues to operate efficiently. GPUs, graphics processing units, play a crucial role in Ethereum mining, being the most widely used hardware component by miners. Unlike CPUs, central processing units, which are designed to handle a variety of computational tasks, GPUs are optimized for parallel computations, making them ideal for the type of work required in mining. In the case of Ethereum, mining requires solving complex mathematical algorithms, known as hashes, which can be processed much more quickly by GPUs. Due to their ability to perform multiple operations simultaneously. This allows miners to achieve significantly better performance in solving proof-of-work problems, increasing their chances of earning the Ether (ETH) reward. In addition to parallel processing capability, GPUs are more accessible compared to ASICs. Application-specific integrated circuits, which are designed to mine more efficiently but are tailored for a single task, like Bitcoin mining. This makes Ethereum mining more inclusive, allowing anyone with a good GPU to participate in the competition. With the increasing use of GPUs, large-scale mining farms, which operate hundreds or thousands of units, have become the backbone of the Ethereum network. Additionally, GPUs can be used across different cryptocurrencies, making them a more flexible investment for miners looking to diversify their operations. However, the use of GPUs also faces challenges. The increasing mining difficulty on Ethereum, driven by rising demand and the network's evolution, requires even more processing power. This has led to increased competition among miners, with those lacking high-quality equipment falling behind. Moreover, the energy consumption of GPUs is another significant factor, as intensive mining can lead to high operational costs, making it essential for miners to find affordable and efficient energy sources. The environmental impact of mining, with GPUs due to their high energy consumption, has also been a growing point of criticism, especially at a time of rising awareness about climate change. The rewards for Ethereum mining consist of two main parts: the reward in the Ether, the native cryptocurrency of the network, and the gas fees. The ETH is the primary reward that miners receive for solving hash problems and validating transactions. On the Ethereum network, the amount of ETH received varies depending on the difficulty of the task and the number of miners competing. Initially, the reward was higher, but over time, the amount of ETH granted per mined block has been decreasing, a practice known as halving. This is done to control the inflation of the currency and ensure that the issuance of ETH follows a predictable trajectory. Therefore, miners not only earn by validating transactions, but also participate in a broader, decentralized economic system. In addition to ETH, miners also receive gas fees, which are paid by users of the network to perform transactions or execute smart contracts. Gas is a unit of measure that quantifies the amount of computational work required to perform an action on the blockchain. Each operation on Ethereum, whether a simple transaction or the execution of a smart contract, requires the payment of a certain amount of gas. The gas price is determined by supply and demand within the network, which can cause significant variations in fees during periods of high demand. Miners, by validating these transactions, receive these fees as an additional incentive to keep the network running efficiently. The dynamic between the reward and the gas fees is crucial for incentivizing miners, but it also creates challenges. As ETH rewards decrease over time, miners increasingly rely on gas fees to ensure profitability. This can lead to greater competition for mining, especially during periods of network congestion when gas fees rise significantly. Additionally, the cost of gas fees can affect the accessibility and usability of the Ethereum network, creating a dilemma between ensuring sufficient rewards for miners and keeping the network accessible for users. Ethereum mining has been the subject of much criticism due to its high energy consumption. This computationally intensive process, carried out by hundreds of thousands of miners worldwide, requires large amounts of electricity. Each block of transactions validated on Ethereum through the proof-of-work algorithm consumes a significant amount of computational power, which in turn leads to massive energy consumption. The energy required for these calculations often comes from non-renewable sources, contributing to the carbon footprint of mining. Furthermore, as the network grows and the difficulty of tasks increases, the energy consumption tends to rise as well, making the environmental impact of Ethereum mining an increasingly relevant concern. The energy consumption of Ethereum mining is particularly important at a time when the world is becoming more aware of climate change and the need to transition to more sustainable energy sources. Cryptocurrency mining, especially Ethereum, has been criticized for its high energy demand, leading to debates about the long-term environmental viability of this model. Countries with cheap energy sources, such as China, were previously major mining hubs due to the availability of affordable power, but environmental concerns have started to push for changes, with several regions implementing stricter regulations. This growing concern about the environmental impact of Ethereum mining is leading to significant changes in how the network operates. Ethereum, recognizing this issue, is in the process of transitioning to a new consensus algorithm called Proof-of-Stake, POS, which aims to drastically reduce energy consumption by replacing proof-of-work. In the POS model, transaction validation is done by validators who stake their own coins rather than relying on massive computational power. This change aims not only to address the environmental issue, but also to improve the scalability and efficiency of the network. Therefore, the future of Ethereum mining is intrinsically tied to the search for more sustainable and efficient solutions. The transition from proof-of-work, POW, to proof-of-stake, POS, represents one of the biggest milestones in the evolution of the Ethereum network. This change was planned to address several critical issues that arose due to the use of POW, such as excessive energy consumption and the network's limited scalability. The POS model aims to improve efficiency and reduce environmental impact while maintaining the network's security and decentralization. Instead of miners competing to solve complex mathematical problems, as in POW, in PS, validators stake their own coins in a process called staking. They validate transactions based on the amount of E they hold and are willing to lock as collateral. This drastically reduces energy consumption, as there is no longer a need for massive computational power to validate transactions. In addition to being more energy efficient, proof of stake also promises to improve Ethereum's scalability. In POS, transactions can be processed more quickly without the bottleneck caused by the high energy demand and the time miners need to solve POW problems. With the increasing adoption of smart contracts and dApps, decentralized applications, on Ethereum, the ability to process more transactions per second without compromising security and decentralization is crucial for the platform's future. POZ offers a more agile and flexible solution to these challenges, making Ethereum better prepared to handle a growing number of users and developers. However, the transition from POW to PAYS is not a simple process. While the benefits are significant, there are technical and operational challenges to ensure the change occurs without compromising the security of the network. One of the most important issues is the redistribution of validation power. As in POW, the ability to mine is related to computational power, while in PEACE, validation power is related to the number of coins staked. This raises concerns about the centralization of the validation process, as large investors may have more power in the network than smaller users. The Ethereum Foundation is working to ensure that the transition to proof of stake is carried out gradually and securely, preserving the decentralization values that are fundamental to Ethereum. The future of Ethereum mining is deeply tied to the transition to proof of stake (POS), but also to new challenges that arise as the network continues to evolve. As more developers and users enter the Ethereum ecosystem, the demand for greater scalability, enhanced security, and faster transactions has never been greater. While POS offers an efficient solution to reduce energy consumption and improve scalability, it also raises new challenges, such as the potential centralization of the validation process, where large ETH holders would have more influence over the network. Additionally, the introduction of new security mechanisms and the adaptation of smart contracts to a faster and more efficient network are areas that require constant innovation and testing. Another important challenge is related to the growing competition in the cryptocurrency space. Ethereum faces fierce competition from other blockchain platforms like Binance Smart Chain, Solana, and Polkadot, which also offer smart contracts and decentralized solutions, but with promises of greater scalability and lower transaction costs. The Ethereum network needs to continue innovating to maintain its position as a leader in the smart contract ecosystem, balancing decentralization with the need for fast and efficient solutions for users and developers. The migration to POS is an important step in this direction, but Ethereum needs a robust model to handle the tensions and pressures of a rapidly growing network. Moreover, the issue of sustainability continues to be a central theme. While the migration to POS is a direct response to the high energy consumption of traditional mining, the long-term sustainability of the Ethereum network involves not just energy consumption, but also the efficiency of the smart contracts and dApps running on it. With the increasing use of Ethereum in decentralized finance, DeFi, non-fungible tokens, NFTs, and other sectors, the network needs to ensure that its solutions are scalable and sustainable without compromising security or decentralization. Therefore, the future of Ethereum mining is intrinsically tied to these issues of constant innovation, adaptation, and sustainability. Ethereum mining as an integral part of the network is more than just a technical process. It symbolizes a revolution in how financial transactions are conducted, how contracts are executed, and how power is distributed in the global economy. Over the years, Ethereum has played a key role in building a more transparent, decentralized, and accessible financial system. Its ability to allow anyone to participate in transaction validation and block creation without relying on a central authority is one of the cornerstones that support the philosophy behind blockchain. This decentralization allows Ethereum to challenge traditional financial systems, offering a more democratic and resilient alternative to the status quo. However, the path to full decentralization is not simple. As we've seen throughout this journey, there are significant challenges related to scalability, security, and sustainability of the network. The transition from POW to POS, for example, is one of the most ambitious initiatives to solve environmental and scalability issues, but it also brings with it new questions, such as the centralization of validation power and the need to ensure a network accessible to all. The Ethereum Foundation and the developer community are constantly working to overcome these obstacles, seeking a balance between innovation, decentralization, and sustainability. The future of Ethereum is constantly evolving. But one thing is certain: the network will continue to play a key role in transforming the global financial system and the way people interact with money and contracts. The digital revolution that Ethereum represents is not just about cryptocurrencies, but about creating an infrastructure for a more transparent and accessible future. As Ethereum continues to grow and evolve, mining, whether through POW or POS, will remain an essential element for the security, decentralization, and functioning of a new financial era.